read some problems. So here is just a function that is piecewise defined function to evaluate it. Find f of -3, find f of 0, find f of 4, something like that. This problem 29 on 94 is reading from the graph, I believe, if I remember correctly. So read from the graph. I'm opening the book right now. So it's on page 94. It's at the end of R. Okay, so 29, yes, it's reading from the graph. F of this, f of that, domain and range. 39 is from chapter 1, again reading from the graph, reading limits from the graph. And the same thing here. Then talking again about limits and how to calculate limits. Number 6 is continuity. We're given a piecewise defined function. We're asked, is this function continuous at 2? We did this also last time. Given a function to find the average rate of change. Of course, the major topic here, the equation of the tangent line to the graph of a function at a particular point. Of course, derivatives, all sorts. The interest compounded or continuously compounded, or continuously compounded interest. To differentiate a product, a ratio, a power chain rule. A function to find increasing, decreasing intervals. Maybe concavity with a second derivative. Finding the min-max, absolute and relative on a closed interval. We reviewed that last time as well. Linearization of a function. We did that last time also. Implicit differentiation, related rates, they are very closely related. Of course, integrals, area, using substitution on integrals. Consumer surplus, producer surplus. Differential equation, domain of a function of 2 variables, and of course related relative max min for functions of 2 variables. I did not put any linear regression. It's just a calculator 1 minute problem. I did not put linear regression on the final exam. Okay. So you tell me what you would like to discuss.
Can we do one of the equation of the tangent line questions?
Yes. Let's start with that. Good. So I picked a function, a very simple function, 2x plus 1 over x. So we have f of x equals 2x plus 1 over x. And we are told when x equals 1, of course, I have to determine the y value. So 2 plus 1 is 3. So the point is obviously 1, 3. So I have y minus 3 equals the slope times x minus 1. But I have to find the slope. So I have the point, but I need to find the slope. In order to find the slope, I have to differentiate and plug in 1. So when I differentiate and find f prime of x, I get 2 minus 1 over x squared. Please remember 1 over x prime is negative 1 over x squared. When I plug in 1, I get 2 minus 1, which is 1. Okay, so f prime of 1 is 1, which is the slope of the tangent line. And now I have to solve for y. So y minus 3 equals x minus 1, and I have to move 3 to the other side, so y equals x plus 2. So this is the equation of the tangent line to the graph of 2x plus 1 over x. at the point that that is given to us, at the given point, 1, 3. So you're given the point, you use the point slope form, you find the derivative, you plug in x, that's your slope, and then you plug it in, and you find the equation of the tangent line. Is this okay?
Thank you.
Perfect. Anybody else? Other questions on this? Was that a good feeling or a bad feeling? Okay.
Maybe 16.
Related rates.
Related rate.
Very good. Very good. So I'm just gonna open on related rates, and that is related rates. Okay. That is in chapter 2. Related rates. No, it's not chapter 2, it's chapter 1, sorry. Okay. Okay. Sorry, it's chapter 3, actually. Okay, found it. Good. So here is something like y equals 5x minus x squared. They're asking us to find dx over dt when x equals -2 and dy over dt equals 2.5. So I picked problem 8 on page 364. Good, so that's related rates. Good. So obviously, this is a clear indication that x and y are functions of a third variable of t, time or something else. So then when I differentiate implicitly here, put a dot underneath, just to remember that this is not a variable. Y is a function of t, x is another function of t. So when I differentiate the left-hand side, I have dy over dt. But when I differentiate the left-hand side, when I differentiate the right-hand side, I have 5 dx over dt minus 2x dx over dt. So let's think for a moment and see if you understand this. So 5 times the function prime is just 5 times the function prime, minus a function squared prime. I bring down 2, I subtract 1 from the power, times the key words are times the inner function prime. Those are the key words, times the inner function prime. I'm asked to find dx over dt, but I cannot combine these, so I must factor out, because they are not like terms. So the left-hand side is dy over dt, but the right-hand side is 5 minus 2x times dx over dt, because 5 times the derivative minus 2x times the derivative are not like terms. Again, I'm after dx over dt, so I can solve it. I can solve this equation now, which is just algebra, dividing both sides by this quantity, because I need to solve for dx over dt. So then dx over dt equals whatever I have on the left-hand side, which is dy over dt, everything divided by 5 minus 2x. So let's stop for a second and see if this is okay. Is this okay?
Yes. Yeah.
Perfect. So now we plug in the given information. What do I plug in? Well, I replace this by 2.5, and I replace x by negative 2. So the top is 2.5, and the denominator is 9. So dx over dt is 2.5 over 9. Good.
1214
Linearization. Good. So the linearization is in the same chapter. Okay, and okay. Okay, so let's look at 23 on 341. And we have f of x equals e to the x. And they're asking us to find L of x when a is 2. So there is just a simple formula, f of a plus f prime of a, x minus a. All you have to do is just plug it in. Find everything, find f of a, so this is e squared. Find f prime of a, which happens to still be e squared because e to the x is the same with its derivative, and this is x minus 2. So the linearization of this function near a equals 2 is e squared plus e squared times x minus 2e squared. We have to combine like terms, so we get e squared x minus e squared, because these are like terms. 1 apple minus 2 apples. And now they're asking us to find e to 2.1 and find which is f of 2.1 and find the linearization of 2 at 2.1 and then find the difference. So I will find an approximation here, and I will find an approximation here of e squared times 2.1 minus e squared, and then the difference. So I will use the graphing calculator, and here it is. Again, this is my preference. I like to see the function. I want to put it in there. It's easier for me. And I think it should be easier for you to do this because it's very easy to plug in something, make a mistake. But if you see the functions in front of you, I think that will be better. And let the calculator do the work. Okay, So I see both functions in there. That's not what I meant. So I see both functions. I see e to the x and I see e squared x minus e squared. And all I have to do is just determine the value instantaneously by plugging in 2.1. So I have both values right there. Highlight them, copy, let's say 3 decimal digits. So the first one is 8.1662 and the other one is 8.1280. And now subtract 8.1280 minus 8.1662 and you get the difference. You should get the positive difference, but it doesn't matter really. I'll give you full credit regardless. If you subtract this minus this or this minus this, it's okay. So the linearization is a very straightforward, as long as you put the formula in and you plug in. It's a plug and chuck. Good. Now, when it comes to these limits, we discussed this, and I'd like to just put the answers here so we can cross this out as well. The limit as x approaches infinity from 3x to the third over 4x to the third plus 1. What is this? What does this equal to?
1.
It's the same degree over the same degree.
It's not 1.
It's the leading coefficient of the numerator over the leading coefficient of the denominator. In the previous example we looked at, I chose 1 over 1. But it's the leading coefficient over the leading coefficient, which means in this case is 3/4.
Oh, it's not the power of the degree?
No. If the degrees are the same, it's the leading coefficient over the leading coefficient.
If the degrees are the same.
And they are the same. The numerator
Yes.
has degree 3 and the denominator has degree 3.
Okay.
Good. What
Okay,
about,
thank you.
sure. What about the second one?
Is that one 0?
Yes. When the denominator is more powerful, the limit is 0. And remember, all this are considering infinity or negative infinity. No other number. I mean, this infinity is a symbol. It's not even a number. But we're not talking about x approaches 1 or 2 or 3 from the left, something like that. We're talking about this particular situation in which we calculate the limit at infinity. And what about the last one?
Would it be positive infinity?
Indeed. Because the numerator is more powerful than the denominator. But careful. If the numerator has, for example, minus, then it will be minus infinity. So you have to be careful. I'm going to delete that. Okay? So you have to think about the sign. The sign is important here. There is no importance here. It's 0. Here it's important, because if it's negative 3 over 4, it will be negative 3/4. So the sign matters here, and the sign matters here. The middle one, it does not matter, because it's 0. Good. Okay. Anything else? I think we can discuss this very fast. This is just algebra, right? Is the slope f of 2 minus f of 1 over 2 minus 1. I think that this is clear. You determine the points, and that's your average rate of change. F of x2 minus f of x1, this is from beginning algebra. Good.
We do 10.
10, 10, 10. Interest compounded continuously. Very good. So there are two formulas that we need to remember. A equals P1 plus R over N to NT. And the other one is PE to RT. This is compounded N times per year, and this is continuously. This one is in R from the review, and this is in chapter 2 when we talked about exponentials. And this is just algebra. There is no calculus here. You just have to plug it in and maybe solve an equation. Should we look for a problem?